Hello everyone. In this video we are going to solve the problem number 1.16 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. So two particles 1 and 2 move with constant velocities v1 and v2 along two mutually perpendicular straight lines towards the intersection point O. So let us consider that this is the point O, and here we are having the particle 1 and it is moving in this direction towards point O with velocity v1. Let us consider another particle, particle 2, which is moving towards O with velocity v2. Okay, and we can see that both are mutually perpendicular to each other. Okay, and then it is saying that at the moment t is equal to 0, the particles were located at the distance L1 and L2 from the point O. So let us say that at time moment of t is equal to 0, the distance between point O and particle 1 is L1, and the distance between point O and the particle 2 is L2. Okay, then it is asking for the time. For that, the distance between the two particles can be minimized, or it will be the smallest. So at what time the distance between those two particles will be the smallest one, and then what is that particular distance. Okay, so let us first consider the what is the distance between these two particles at the time moment of t is equal to t. Okay, so let us say that the particle has moved by a distance of v1 into t in the time t, and the particle 2 will move by the distance of v2 into t in time t. Okay, now at time t, this is the location of particle A and this is the location of particle B. Now in order to find the distance between these two particles, we can draw a straight line between these two particles, and we can see that the triangle OAB is a right angle triangle. Okay, so from here the distance between these two particles we can write AB is equal to OA whole square plus OB whole square under root from Pythagoras theorem. We know what is the distance between O and A. Initially the distance between point O and particle 1 was L1, and later on it has moved by the distance of v1 into t. So now the distance between O and particle 1 is L1 minus v1t. Okay, and distance between O and particle B is L2 minus v2 into t. So the distance AB, we can write it as what is OA, L1 minus V1t whole square plus what is OB, L2 minus V2t whole square under root. Okay, so this is the distance between two particles at time instant t. Okay, now in order to find the time at which this distance will be smallest, for that we can differentiate the expression of AB and then we can equate it to 0, and from that we can find the time which for that the distance will be the smallest one. Now in order to find the minimum value of AB, instead of differentiating the whole expression, we can just differentiate the function inside the square root, and then we can find the minimum value instead of doing the differentiation of the entire expression. Okay, so let us consider that AB square is equal to L1 minus V1t whole square plus L2 minus V2t whole square. Let us expand this particular expression, then we can get L1 square plus V1 square T square minus 2L1 V1 into T plus L2 square plus V2 square T square minus 2L2 V2 into T. Let us rearrange the above expression. We can get L1 square plus L2 square plus V1 square T square plus V2 square T square minus 2L1 V1T minus 2 L2 V2T, and this is the value of AB square. Now we will differentiate this particular equation and we will equate it to 0. So let us differentiate the value of AB square with respect to time. Then the differentiation of L1 square is equal to 0 because this is constant, and the differentiation of L2 square is equal to 0 because this is also constant, and here V1 square is constant, so the differentiation of T square is 2T, so we can write 2 V1 square into T, and here the differentiation of T square is 2T, so we can write 2 V2 square into T, and here 2 L1 into V1 is constant and the differentiation of T is 1, so we can write 2 L1 V1 minus 2 L2 V2, and the whole term we can equate it to 0. And from here, if we solve this particular expression, we will get T is equal to L1 V1 plus L2 V2 whole divided by V1 square plus V2 square. So this is the time at which the distance between those two particles will be the smallest one. Okay. Now we have to find that particular smallest distance. For that, what we can do, we can substitute the value of this particular expression in the equation of AB, and then from here we will get the smallest distance. But it might be a tedious task to do, because here we are having this particular expression and we have to do the square of that, and then we have to rearrange several terms in order to get the minimum value of the distance. For that, what we can do, we use the concept of the relative velocity. We use the concept of the relative velocity to find the minimum distance. Okay, let us draw the configuration again. For example, this is point O, and here we were having the particle 1 which was moving in this direction with velocity v1, and here we are having particle 2 which is moving in this direction with velocity v2. Okay, and then we have set, like, let us say if we make the particle 2 at rest, then the particle 1 will move with velocity of 1 with respect to particle 2. Okay, so for example, we are having the velocity of particle 1 in this direction and velocity of particle 2 in this direction. This is the velocity of particle 1, this is the velocity of particle 2, and if we write the velocity of 1 with respect to 2, then what we can write? Velocity of 1 minus velocity of 2. Basically this is what velocity of 1 plus of minus velocity of 2. So basically we will add the opposite of v2 in the v1. Okay, so let us do that. So this is the opposite of velocity of 2, and the resultant of these two velocity we will get it as the velocity of 1 with respect to 2. And as both the vectors are perpendicular to each other, so velocity of 1 with respect to 2 we can write v1 square plus v2 square under root. So now if we make the 2 is at rest, then the particle 1 will move with the velocity of v1 square plus v2 square under root. Okay, now the particle 1 will go in this straight line, Okay, and we know that the distance between this line and particle 2 will be minimum when the line joining these two particular points on this line will be perpendicular to each other. So when this line is perpendicular to this particular line on which the particle is moving with respect to particle 2, then we can say the distance between these two particles will be the minimum one. These two will be minimum. Okay, now let us find this particular distance. For example, let us say this is point A, this is point B, and this is point C, and this is point D, and let us assume that this particular angle is theta. Okay, so from the vector diagram we can find that tan theta is equal to V2 divided by V1. Okay, and let us say this particular distance is x, and the overall distance between O and D was L2, and this distance is L1. So OB we can write L2 minus x. Okay, so tan theta we can also write it as this particular distance divided by this particular distance. This distance is how much? L2 minus x divided by what is this distance? This distance is L1. So let us equate these two tan theta. So from here we will get V2 upon V1 is equal to L2 minus x divided by L1. Okay, so from here we will get x is equal to L2 minus L1 V2 by V1. So from here we will get V1 L2 minus V2 L1 whole divided by V1. So this is the value of x we will get. Now this is the value of x we got. So if this particular angle is 90 degree, so this angle will be 90 theta if this angle is theta. Okay, so the opposite angle will be how much? 90 minus theta. So this angle will be 90 minus theta. So what is the minimum distance? Minimum distance is nothing but CD, and CD we can write BD times BD into sine 90 minus theta, that is BD into cos theta. And what is the value of BD here we have got is x. So we can write x into cos theta. What is the value of x we got from here? V1 L2 minus V2 L1 divided by V1, and we know tan theta is equal to, from here we have got the value of tan theta, that is V2 divided by V1. So cos theta we can write V1 divided by V1 square plus V2 square under root. Okay, so if for example if we draw the triangle here, and let us say this particular angle is theta, and this is V2, this is V1, this is V1 square plus V2 square under root. So cos theta we can write V1 divided by V1 square plus V2 square under root. Okay, so value of cos theta we can substitute here. This is V1 divided by V1 square plus V2 square under root. So from here we will get V1 L2 minus V2 L1 whole divided by V1 square plus V2 square under root. Now this is the value of minimum distance. Minimum distance. We have to put the mod here, because if the V1 L2 is greater than V2 L1, then it is fine. If V1 L2 is less than V2 L1, then the term inside will be negative. That's why we have to put modulus here. Okay, I hope the entire procedure is clear. What we have done, first of all, we have found out the distance between point A and B at any time moment of t, and then we have found out the expression of this particular distance in terms of time, And in order to find that smallest distance, we have to differentiate that particular expression with respect to time, and then we have found out the time at which the distance is minimum. And we have seen that if we substitute this particular expression here, we can find the distance, but this is somewhat the tedious task. So for that we have used the concept of relative velocity, and from the geometry we have found out the minimum distance CD here from the geometry. I hope the procedure is clear. Thank you.